Welcome back to my channel. This is Kingdom Muju from KD Concept Researchers. Please kindly like and subscribe to our channel so that you can always get our videos while it drops. Now, so we can use correlation such as the present moment correlation to test if there is a linear relationship between variables. Now, it is good to know, to check if there is a linear relationship between variables, because variables that does not correlate may not give you a very good model. So there must be a linear relationship between these variables which are to be added to any model to be able to get a good model. So that is why we check for correlation. Now, for correlation, of course, we can also check for correlation using this data which we are already using. I want to check for correlation between the nominal GDP, demand deposits, credits to private sector, money supply, and narrow money. All I have to do again for correlation analysis is to go back to my data, then click on data analysis. Now, in this data analysis tool here, I'm going to press C on my keyboard. You see correlation. Okay. Now, in correlation, it's just asking you to enter your data range. I'm going to select the entire data, both dependent and independent variable. I will highlight the entire data range. Good. Now, they're asking me, how did I group my data? My data is grouped according to row. So, according to column. So, I will select column grouping. And then let the label be on the first row. And also let my output be on the new sheet. I always like to put my output on the new sheet so that I can see it clearly. Then I will OK. Now, this is how correlations work. Let me highlight all this. Remember, I can highlight the entire, double click on any line. It gives you the full. Now, if you look at this correlation analysis, you see that correlation between nominal GDP and nominal GDP is exactly 1, which is 100% correlation because it's the same data. The same happens between demand deposits and demand deposits. So between the same data point is 100% correlation. That is not our interest. Our interest is in interacting parameter. For instance, between demand deposits and nominal GDP, the correlation is 0.89. This is a highly positive correlation. Also, if you look at, in fact, basically looking at the entire data and the entire output, you find out that there is a high positive correlation between these both the predictors and the predicted variable. That's the correlation is very fine. This is a very fine correlation here because they are all above 0.5, showing a strong positive correlation. That means there is a good relationship, a good linear relationship between nominal GDP, demand deposits, credit private sector, money supply, and narrow money. So this is a very good way to check for correlation analysis. Again, I have a fine data here which we are going to use for correlation. Now, this data is data from water samples. Water samples, about 8 water samples here. You can see in this place, we have to compute the mean and get the standard deviation. I believe that's very simple. Of course, remember what we do in mean, that you can just say equal to average equals to average. Then you open your brackets. Then you need to come and highlight the entire data area and close. Enter. You have your mean. Now you just need to bring your cursor to this side to make the plus, double click. Then you have all your mean values for each of these bubbles computed. Similarly, for the standard deviation, the function, remember you must start with equal to for every function. Function is stdev. So stdev open brackets. I will still highlight the entire data again, but not including the mean. Close it. Sorry. I'll have to highlight the entire data from OGB1 to OGB8, which is the label here. Then I'm OK. Now that's the standard deviation. I will also filter it down. To do this, all the merged cells need to be of same size. Okay, this value here did not show any value. Okay, leaving that for now, our interest is on correlation analysis. Now, if you look on the first here, we see parameters. We have parameter 1, 2, 3 that we are tested, which is these are physicochemical parameters. Physicochemical parameters. Of course, these are the things they check to know how healthy water is. Now, our interest here is to check if there is a correlation between these parameters, including temperature, pH level, conductivity, turbidity, and the rest of them. That means this time around now, my analysis is not going to be based on column, but rather it will be based on rows. How do we do that? Again, we go back to our data, then click on data analysis. Again, we select correlation and OK. Now, inside this input range, I'm going to remove whatever data that was there already. I'll come back here and highlight this data, not including the mean, but just the data points. There are about 17 of them here. Now, they're asking me, how did I group my data? I said the group is by rows. Now, I'm going to change this. It's no longer by column. I want to group it by rows, which is the parameters here. And of course, let label now be on the first column. The first column here is going to contain our label. Where is the first column? This is the first column here, the parameter column. Let it be our label. And now I've highlighted the entire range. Then I'm okay. Good. This one gives us a very big data because there are about 17 here. Now, in this correlation here, we see both positive correlation and negative correlation. For instance, between pH and turbidity, we see a negative correlation. Now, let me say the ones on negative correlation, I will highlight it with red. I can use red. Then, of course, between conductivity and turbidity is a highly positive correlation. Maybe the ones that are positive, I can just put a blue color. Good. No, not font, but fill. Font color, I can even use white. Good. Now, you see the difference? This one here is a negative correlation. Remember, we say correlation can be negative, positive, or zero. Now, why this one here shows a positive correlation? You also observe that there is a trail line of 1, 1, 1, 1. This one showing 1 is the correlation of a parameter with itself, which is 100% linear relationship. However, our interest is not on that first ones, but the other ones here. For instance, if I click on this one, this is the correlation between turbidity and, of course, this element here, sodium, which is 0.6. It's showing a highly positive correlation. So basically, this is how to do correlation analysis. Now, one may want to move this data to Microsoft Word, where you can, of course, prepare your document very well. So if I want to move it, all I have to do is to highlight the entire range, right click, and then copy it. Okay, I didn't share my Microsoft Word document. So all you have to do is copy it, then you go to your Microsoft Word. If you look at this, I found out that this represents the landscape page. So you also need to paste it on the landscape page and adjust your rows to fit in the data very well. However, you can also print it directly from Microsoft Excel if you so desire. So this is simply how to conduct regression and correlation. Thank you for watching this video. You can also check out some other videos that are prerequisite to this one on our course series in data analysis using Microsoft Excel. Please kindly leave your questions in the comment section and we'll attend to them. Also remember to like, share, comment, and most especially, please kindly subscribe to this channel so that we can always serve you better. Thank you.